Hello students, here we have a problem from permutations and combinations, geometry based question here. Now you see the question is like this. There are 12 points in a plane. So totally you have 12 points. Okay, in a plane there are 12 points, and you see out of that 12 points, 5 points lie on a straight line. 5 points on a straight line except for these points, means except these 5 points no other 3 points are collinear, means no 3 points lies on a single line except these 5 points. So you can imagine in a plane there are 12 points like this, 1 2 3 like 4 somewhere like this. Totally you have 12 points, but no 3 are collinear in that. No 3 are collinear like this, but 5 points are collinear, right? For example, if I take 1 2 3 4 5, so these 5 points lie on a single line, and remaining 7 points, okay, 12 minus 5, the remaining 7 points, in these 7 points no 3 are collinear, no 3 points lie on a single line. That is the information given to us. And what you have to find out here, we have to find out the number of straight lines can be formed using these points. Using these points, how many straight lines can be formed, the first question. And the second question is the number of triangles, how many triangles we can form with the help of these 12 points, okay, according to that condition, right? 5 points are collinear is given to you, and 7 points in that no 3 points are collinear. And the third question is the number of quadrilaterals can be formed by joining these points, okay. First of all, you have to find out how many straight lines can be formed, right? So we'll concentrate on the first question now. Let's see now. Whenever you want get a straight line, right? For example, if I select this A point and B point, so by joining these 2 points I can get a line like this. If I join these 2 points, I'll get one more line. If I join these 2 points, I'll get one more line. What is the meaning of this? Can you tell me what is the meaning of this? Each pair of points gives a line, right? Each pair of points give a line. So whenever you have a pair of points, by joining them you will get a line. So how many pairs of points are there, that many lines will be there, right? So here we have 2 points, so you got a one line. Here we have 2 points, you got one more line. Here we got 2 points, so you got one more line. So like this, how many pairs of 2 points, how many pairs of points are there, that many lines we can draw. So what is the meaning of this? How many ways? The question is like this. The number of straight lines can be formed. The equivalent question we can ask like this. How many ways we can select, how many ways 2 points can be selected? How many ways 2 points can be selected? For the first question, the equivalent question is this. How many ways you can select 2 points? If you say I can select 2 points in 10 ways, if I say I can select 2 points in 10 ways, then there are 10 lines, because of one way you select 2 points, then I can draw a line, and you select one more way, I can draw one more line. You select one more pair of points, I can draw one more line. So like this, how many ways we can select 2 points, that many straight lines we can draw, because of each selection gives you a single line. Each selection of pair of points gives you a single line. So how many straight lines can be formed? This is nothing but how many ways you can select 2 points, right? So now you see the first question, the answer for the first question is the number of straight lines. The number of straight lines can be formed is equals to the number of straight lines. The number of straight lines can be formed. The number of straight lines can be formed is equals to what? The number of ways of selecting 2 points, correct? The number of ways of selecting 2 points. So generally there are 12 points, right? Without seeing any condition, we'll see this condition later. Let us suppose you don't have any condition like this, okay? All the points, 12 points are not collinear, any 3 are not collinear. Then how many ways you can select 2 points from 12 points? How many ways you can select 2 points from 12 points? That we want, right? So that is what 12C2. Number of ways of selecting 2 points from 12 points is 12C2. But here we have a problem. What is the problem? among these 12 points, out of these 12 points, 5 points are collinear. What is the meaning of this? If you join these 2 points, you will get a line which is same as joining these 2 points, which is same as joining these 2 points, which is same as joining these 2 points, or which is same as joining these 2 points, or which is same as joining these 2 points. So what is the meaning of this? From these 5 points, if you select any 2 points, it gives only a single line. It gives you a single line, not all are different line, that is a single line only. Okay, so that means out of 5, if you select 2 points, it means how many ways you can select 2 points? 5 C2 ways. 5 C2 ways, you can, if you want to calculate, you can calculate this. 5 C2 is 5 into 4 by 2 into 1, which is what? 2 2s are cancelled, so 5 2s are 10. So there are 10 pairs of points, right? 10 pairs of points you can get here. But out of that, every time whenever you join 2 points, you are getting a single line, but we are counting here as 10 lines, correct? So therefore this 10 should be subtracted from 12C2, and if I subtract this minus, what I have to write? 5C2. But if you subtract all these 10, this one single line is going to miss, so that's why we will add 1 at the end, because of instead of counting 10, we have to count as 1. So we'll subtract 10 and we will add 1. Okay, simply we can subtract 9 also, but it's better to do like this. Okay, so in general way, if you are thinking about the same problem, let us suppose I say n points given in a plane among which m points are collinear. M points are collinear. Out of n points, m points are collinear. Then how many straight lines can be formed using these points? If this is a question, then the answer will be what? From n, you select 2 points, that gives the number of lines. But from m points, if you select any 2 points, that gives the same straight line every time. So we have to subtract that mc2 and add that single line at the end, nc2 minus mc2 plus 1. Right? I hope you understood. So number of straight lines can be formed is equal to what? 10C2 minus 5C2 plus 1. Why we subtracted 5C2, you should understand, because of the 5 points are what? Collinear, right? 5 points are collinear. If the 5 points are collinear, if you select any 2 points from these 5 points, you will get a single line every time. Each pair gives you a single line. Each pair gives you a single line, right? Not 5C2. So that's why we are subtracting 5C2 and then we are adding that single line at the end plus 1. Okay. Now see the second question. What is the second question here? The number of triangles can be formed. How many triangles can be formed using these 12 points? Let's say you have 12 points somewhere here like this again. Let's say here we have a point and here we have a point. So like this 12 points totally are there, but among which 5 points are collinear like this 3, 4, 5. These 5 points are 1, 2, 3, 4, 5. These 5 points are collinear. Okay, now to form a triangle we need 3 points, right? So whenever you select 3 points, you will get a triangle. Whenever you select 3 points, you will get a triangle. So any 3 points gives a triangle. So the question is, how many triangles can be formed? The question is, how many triangles can be formed? What is the meaning of this? How many ways you can select 3 points? If you select 3 points, you will get one triangle. If you select another 3 points, you will get one more triangle. Like this, if you select any 3 points, you are going to get one triangle. So 3 points gives you one triangle. So how many 3 points are there? That many triangles you are going to get. So therefore, how many triangles can be formed? The equivalent question is, how many ways you can select 3 points, right? How many ways you can select 3 points from these 12 points? That is the question. So here we have 12 points. Here we have 12 points. From 12 points, how many ways you can select 3 points? Okay. From n objects, if you want to select r objects, what is the formula we have? What is the result? We have NCR. So from 12 points, if you want to select 3 points, how many ways it can be done? 12C3. So here we can get the number of triangles. The number of triangles can be formed. The number of triangles can be formed is equals to what? 12C3. Now once again here we have a problem, because of here 5 points are collinear. Here we have 5 points are collinear. If you take any 3 points from this, if you select this one, this one, this one, you are not going to get any triangle. But what we counted in this, any 3 points counted as one triangle. Joining any 3 points, you are saying one triangle will be formed, right? So but in this the counting is wrong, because of these 3 points does not give any triangle, and if I select this, that also not going to give any triangle. So therefore from these 5 points, if you select any 3 points, you are not going to get a triangle, because of they are collinear points, right? So therefore from 5, how many ways you can select 3 points? That is 5C3. Okay, so these number, if you calculate this, you are going to get 10 here. The 5C3, 10 triangles actually should form, but they are not going to form, right? Because of they are collinear. So therefore what you have to do here, minus 5C3. Okay, so the number of triangles can be formed is 12C3 minus 5C3. If you want, you can calculate all these numbers. For example, here 12C2, if you want to calculate 12 into 11 by 1 into 2 minus 5C2, you will get 10 somehow, right? So 2, here you can cancel 2, 6, 66 minus 10, 56 plus 1. So therefore you get 57 straight lines can be formed. Similarly, if you want, you can calculate this also, 12C3 minus 5C3, which is what, 12 into 11 into, I hope how to calculate this, you know. So by 3 into 2 into 1, and minus 5C3 is same as 5C2, which is 10. So here 3 to the 6, 6 to the 12. Then you can get here 22 into 10, 220, and minus 10, which is equals to 210. So 210 triangles can be formed in this, right? So now the next question is, if you want to write the generalized formula for this, let us suppose I say n points given to us. How many points? N points given to us, among which m points are collinear. If I say m points are collinear, then how many triangles can be formed? So simply from n you select any 3 points, that gives the number of triangles. But if you select any 3 points from collinear point, you are not going to get any triangle. So therefore we subtract this MC3. Okay, NC3 minus MC3 as a general formula. You can, if you want, you can remember this also. But remember the logic, remember the concept, right? So whenever you want a triangle, we need 3 points, so that's why we always select 3 points. But whenever some points are collinear, that does not give any triangle, so that's why we subtract that number 5C3. Now the third question, is what? How many quadrilateral forms? How many quadrilateral can be formed? So quadrilateral means we need 4 vertices, right? So simply the number of quadrilaterals can be formed. What we will write here, the number of quadrilaterals can be formed means we have 12 points totally. We have 12 points. We want quadrilateral means we want 4 points. Whenever you select a 4 point, that is going to form what? A quadrilateral. So how many ways you select 4 points from 12 points? N objects given to you. How many ways you can select R objects is NCR. So therefore 12 objects given to you to select 4 objects. The result is 12C4. Okay, now you see here we have to think again, because of some problem is there in this, because of collinear points given to you. Okay, let's write first this 12C4. What do we want here? The number of quadrilaterals can be formed in generally. What we have to write is 12C4. Now once again you see here 12C4. So here we have actually how many points? 5 points are what? Collinear, and the remaining 7 points we have somewhere, out of which no 3 are collinear, like this you have. It's totally 12 points. Now you see here, from these 5 points, if you select any 4 points, say 1, 2, 3, 4, these 4 points if you select and join, you are not going to get any quadrilateral. If you select this point, this point, this point, this point, again you are not going to get any quadrilateral. So therefore from these 5 points, if you select any 4 points, you are not going to get any quadrilateral, which is counted here already. Because of 12C4 means any 4 points. So that 4 points may be from these 5 points also. That's why we have to subtract what? 5C4. So we have to subtract 5C4, because from these 5 points, if you select any 4 points, it is not going to form any quadrilateral. So that's why we have to subtract that 5C4 from 12C4. And one more thing here, we have to see some, still there is a problem in this. See here, selecting 4 points means, randomly selecting any 4 points means, let's say out of these 5, if you select any 3 points and 1 point from the remaining 7, okay, you select 1 point from 3 points from what? These 5 collinear points if you select, and 1 point from the remaining 7 points if you select, what will happen? You see here, once check this, 1 2 3 4 5 points are collinear, and somewhere you have remaining 7 points. Like this you have remaining 7 points, among which no 3 are collinear. Like this, let us suppose, not 7 they are actually, so let's say like this, totally 12 points are there. Now if I select any 3 points on this, if I join these 3 points, it's a line, and if I select 1 point from the remaining 7, so what I am going to get here, you see, we are going to get a triangle. We are going to get a triangle, but what we want is not triangle, we want is quadrilateral. So therefore, in this 12C4, this selection is also included. What is the meaning of 12C4? You know what is the meaning of 12C4? Selection of any 4 points from this total 12 points. Out of this 12 points, selection of any 4 points. So therefore, this is 1 point, this is the second point, this is the third point, this is the fourth point. So this 4 points collection is also counted in 12C4, right? This counting is also there in 12C4, but which is not a quadrilateral. So therefore, this type of selection also we should exclude, we have to remove from our counting, right? So what is this? If you select any 3 points from 5, how many ways you can do that? 5C3. So if you select any 3 points from this 5 point, that is 5C3 ways can be done, and 1 point from the remaining 7. 1 point from the remaining 7 can be selected in 7C1, which forms not a quadrilateral, which forms a triangle, which should be excluded from 12C4, right? So something happened with the laptop, so that what I explained was erased. Okay, so let's continue this. The third one, what I am explaining is the number of quadrilaterals can be formed by joining these points, right? So what is that? What I told, out of 12 points, if you select any 4 point, that gives the number of quadrilaterals 12C4. But we are saying that if there are 5 points are collinear, if you select any 4 points from this, you will not form a quadrilateral, it is not going to form a quadrilateral, so that we are subtracting 5C4. And one more time, one more thing, what we have to exclude is, just now I explained that. Okay, so what is that? If you select any 3 points from 5 and 1 point from the remaining 7, that gives a triangle, right? So therefore, that should be excluded once again. So what is that? How many ways you can select 3 points from 5? That can be selected in 5C3 ways, and from the remaining 7 points you can select 1 point in 7C1 ways. So therefore, minus 5C3 into 7C1. I hope you understood this, right? So the number of quadrilaterals can be formed. How many quadrilaterals can be formed is 12C4 minus 5C4 minus 5C3 into 7C1. If you want, you can calculate this number using the calculations of using NCR formula, right? Now, if you want to generalize this, the third question, if you want to generalize this, what we can do here, let us suppose n points given in a plane. If n points given in a plane, among which m points are collinear, m points are collinear, so how many quadrilaterals can be formed? So to form quadrilaterals, we need 4 points from n points, so we'll write nc4. But from m points are collinear, if you say, what will happen if you select any 4 points from these, you are not going to form any quadrilateral, so therefore we have to subtract that counting minus mc4. Once again, if you select any 3 points from this, that is mc3, and 1 point from the remaining points, totally n points, m points are collinear, so remaining points are n minus m. So from this, if you select 1 point, like this here I explained in this particular problem, 3 points from 5 collinear points and 1 point from the remaining 12 minus 5, 7, right? From the remaining 7 C1. So here remaining means n minus m C1, right? So this gives you the number of quadrilaterals. Okay, number of quadrilaterals can be formed. So right, So with this we have learned something about geometry, right? Permutation combinations in geometry. So we are going to see some more advanced problems in the next video lesson, right? So if you like this video, subscribe to the channel. More videos I can make if subscribers are going to increase, right? Thank you for watching.